Have you ever wondered what makes some engines so powerful? The answer lies in superchargers and turbochargers, forced induction systems that boost engine power by compressing air above atmospheric pressure. While both increase horsepower, they differ in their mechanisms and characteristics. When comparing turbochargers and superchargers, it's essential to understand their fundamental differences in operation and characteristics. Turbochargers use the engine's exhaust gases to spin a turbine, which in turn drives a compressor that forces more air into the engine's cylinders. This process makes turbochargers more fuel efficient than superchargers, as they don't directly consume engine power. However, turbochargers typically provide their maximum boost at higher RPMs. In contrast, superchargers are mechanically driven by the engine's crankshaft, directly consuming a portion of the engine's power output. This results in an immediate boost in power and torque across the entire RPM range, making superchargers ideal for applications that require instant acceleration from low engine speeds. However, this direct mechanical connection also contributes to reduced fuel efficiency compared to turbos. Turbochargers offer several advantages that have contributed to their widespread adoption in modern vehicles. They can significantly boost an engine's power output by forcing more air into the combustion chambers. This allows smaller engines to produce power comparable to larger, naturally aspirated engines, resulting in better acceleration and overall performance. By using smaller turbocharged engines, vehicles can achieve better fuel economy compared to larger, naturally aspirated engines with similar power outputs, and when combined with advanced technologies like direct fuel injection and variable valve timing, can produce lower emissions compared to larger, naturally aspirated engines. Unlike turbochargers, which can suffer from turbo lag, superchargers provide an instantaneous boost in power since they're directly driven by the engine's crankshaft. This makes them ideal for applications that require immediate acceleration from a standstill or low engine speeds. Superchargers excel at providing a strong boost in torque at lower RPMs, resulting in improved low-end performance and responsiveness. Lastly, superchargers are generally less expensive than turbocharger setups, making them a more cost-effective solution for those seeking moderate power increases. Both turbochargers and superchargers require careful attention and adherence to manufacturer recommendations. Turbochargers operate under extreme temperatures and pressures, necessitating the use of high-quality synthetic oils and regular inspections for wear and tear. Common issues include turbo lag, boost leaks, and potential failure of components like seals and bearings. Superchargers, while simpler in design, can also experience wear and tear due to the direct mechanical connection, potentially leading to issues like belt slippage or premature failure of components like bearings and clutches. To mitigate potential issues and ensure optimal performance, it's crucial to follow manufacturer recommendations for maintenance and use high-quality lubricants designed for forced induction engines. Regular inspections and timely replacement of components can help extend the lifespan of these engines. Thanks for watching.